Diode. So what is a PN junction diode? A diode is a device which allows only unidirectional flow through its terminals. So why does it happen? A PN junction diode is formed of an N-doped semiconductor side and a P-doped semiconductor side. N-doped semiconductor side is more rich on electrons and P-doped semiconductor side is more rich on holes, due to which the electrons from N-doped side goes to the P side and the holes from P side diffuse to the N side, due to which a diffusion current is formed. After some time, the N-doped side becomes positively charged and P side becomes negatively charged, due to which an electric field is formed, due to which a reverse drift current is formed. When the diffusion current and the drift current becomes equal, a depletion region is formed which has a barrier potential across its terminal. So when do we call a diode forward biased and when do we call it reverse biased? When we join the N-doped side to the negative terminal and P-doped side to the positive terminal, it is called forward biased, and the current flows through it when the external potential is more than the barrier potential of the diode. The barrier potential for silicon diode is 0.7 volts and for germanium diode it is 0.3 volts. When we join the N-doped side to the positive terminal and P-doped side to the negative terminal, it is reverse biased and no current flows through the diode.
I am here to explain the use of diode as a rectifier. So what is a rectifier? A rectifier is an electrical device which converts a AC source to a somewhat DC source. So we have two types of rectifier. First, the half wave rectifier and the second is a full wave rectifier. In a half wave rectifier, we use a diode in series with a load. So when we know that the diode conducts only when it is forward biased. So when the potential between the points A and B is positive, then the diode acts as a short circuit, and when the potential between A and B is negative, that is when B is at higher potential, then this diode acts as an open circuit. So for this type of input, we have this output. When A is at higher potential till this half cycle, we have the same output, and when A is at lower potential than B, then we have no output as seen here. One problem of this half wave rectifier is that we get a discontinuous output. Instead, in a full wave rectifier, we get a continuous output like this. This can be achieved by two types of configuration. One is a bridge configuration and the second one is a center. Okay, ready? And the second one is a center tap configuration. In this we use transformer and the center of the transformer is tapped like this. When the above point is at higher potential, then this diode conducts, and when the lower point is at higher potential, then this one conducts. So then we get an output like this as shown here. To get a DC output, we use a capacitor in series with a resistor. So in the first cycle, the capacitor first gets charged, and since the frequency of the AC source is much higher, the capacitor does not have enough time to get discharged. So it discharges to a little bit and then again charges, and the output is like this.
Diodes are also used in clipping and clamping circuits. The first figure clearly depicts a typical clipping circuit. If we apply an AC waveform like this, we get an output like this. We can see that this waveform gets clipped by a particular value which depends upon the polarity and EMF of the battery. The second one is clamping circuit. This diagram depicts a typical clamping circuit. If we apply an AC waveform like this, we can see the waveform gets shifted by a particular value which depends upon the polarity and EMF of the battery.